Okay, let's take a look at the arteriole. Let's take a cross-section cut of it, all right? And see what happens to the diameter of it, the radius or the diameter of it, right? When the wall, if within that wall, like I said, the arteriole has mostly that smooth muscle there, right? So when you have the smooth muscle contracting, that's going to cause vasoconstriction, thus decreasing the actual radius or diameter. But when the actual smooth muscle relaxes, okay, then that's going to cause vasodilation, and that's going to increase the radius or diameter. Right? Let's see how that affects what we call peripheral resistance by looking at that equation again. Right? Now, again, we're not going to focus on length of the actual vascular system or the viscosity of the blood. We're going to look at what we consider the radius, the vessel radius. Right? And that's because that's what the smooth muscle is actually changing. That's what does change consistently in your body. Right? And then we're going to remind ourselves that in this equation, the radius has an inversely proportional relationship to peripheral resistance. It's that easy. Just keep going back and forth, just like in the respiratory system when we did with hydrogen ion and pH. All right, make sure that you just keep going back and forth with the fact that if radius increases, then peripheral resistance decreases. If radius decreases, then peripheral resistance increases. That's what I want you to do. Rewind that if you want a whole bunch of times, but it's that simple. All right, and then it comes second nature after a while, right? So basically, let's go through this process, do the activity, and seeing how that is related, okay? And so if I should actually have my arterial vasoconstrict, I've decreased the radius. So therefore, your peripheral resistance, right, increases, okay? If I should actually vasodilate, then that means the diameter or radius increases, right? And that means my peripheral resistance, what? Decreases. All right, so that's all you have to keep doing, right? Vasoconstriction, decrease radius, increase peripheral resistance, right? And then you have vasodilation, right? Which you have increased diameter, increased radius, then that means, right? Decrease peripheral resistance, okay? So that's what we're doing. That's just as simple as it gets, and that's why it's very important because that's related to blood flow, okay? Just like Interstate 95, right? If we have Interstate 95 only being 2 lanes instead of the 5 or 6 lanes, right? That's decreasing the radius diameter, right? So what are you going to get with traffic, right? You're definitely going to have what? Increased resistance, all that congestion, right? And you're going to decrease the flow of traffic. You see? All right, so that's how simple it is, right? You visualize that with the Interstate 95, right? If you actually have all of those lanes open on Interstate 95, 5 to 6 lanes, right? Increasing the diameter of it, then what happens to you decrease the resistance, right? You decrease the resistance, you got good traffic, good flow of traffic, right? Good blood flow. Same thing, okay? So just keep going back and forth as it relates to that, and then we'll see now how we have our smooth muscle contraction of what? Arterioles. Don't forget, this is happening with what? The arteriole. And that's how that's going to dictate how blood flow changes, okay? All right. So, and now we can relate what we consider this resistance now to pressure, mean arterial pressure. Because if I should actually multiply peripheral resistance on both sides of the equation, okay, peripheral resistance, right, then I'm going to be able to cross out my peripheral resistance over here, okay? And now I have an equation that solves for mean arterial pressure. So now I have peripheral resistance multiplied times blood flow will give me a mean arterial pressure. All right, so let's do that now, right? If I've actually contracting more of that smooth muscle in the wall of an arteriole, I get vasoconstriction. Decrease my radius, decrease my diameter. That's Interstate 95 being only 1 lane, right? And now what happens to peripheral resistance? Increase. I increase peripheral resistance. Now it's directly proportional to pressure. And so now I've increased my mean arterial pressure. Right? So yes, making that Interstate 95 just 1 lane, which is vasoconstriction and non-systemic circulation, right? is actually going to increase peripheral resistance, increase your blood pressure. Right? So when you have that vasoconstriction, you're increasing blood pressure. That's what vasoconstriction indicates. Vasoconstriction throughout your whole system indicates increasing pressure. Okay? Versus if your smooth muscle relaxes, okay, smooth muscle relaxes, then now what are we going to get? We're going to get increased diameter there. That's Interstate 95 being about 5 to 6 lane, right? And now what happens to peripheral resistance? You decrease it. You decrease peripheral resistance, then now what do you do to mean artery? You decrease that because they're directly proportional now, right? Right? So that's our relationship with when the arterioles are vasodilating and vasoconstricting. There is a direct relationship to pressure, blood pressure. And how important is that? Everything. Because now that's related to how oxygen and nutrients is getting to tissue, right? And also whether it's too high. Let's say blood pressure is too high. Now that's going to delicate tissue that's going to get damaged. And we want to prevent that. So what's going to control all that is your brain. Your brain is going to control that with a group of neurons called the vasomotor center. And they're going to take a signal specifically to that effector, which is considered the arteriole. The what part of the arteriole? The wall of it, which is the smooth muscle. So the effector in that homeostatic process related to the vascular system is your smooth muscle. Whether it contracts, creating vasoconstriction, or relaxes, creating vasodilation, it will have an effect on peripheral resistance, and then it will have an effect on arterial pressure, your blood pressure throughout your entire system, systemic circulation. So that is huge. That's what's related to how your brain now can control blood pressure. That's what we're saying. Your brain, a group of neurons in the medulla oblongata called the vasomotor center, will be able to control blood pressure. Right? And we can see it now based on the equation and how our effectors are controlling that process.